with matrix number 63007. So today I'm going to explain about what is unique about organic synthesis. The first part is that we are able to know, as a consumer, we are able to know what is the content of the product that we are going to use daily. For example, the fragrances, the shampoo, the medicine, and all that stuff. So what do we know about our daily use stuffs such as food, fragrance, facial cleanser, and more? Most of us only know the name, but not the content, right? So this is where organic synthesis is important. Besides, with all the knowledge we gain from organic synthesis, we are also able to produce some new product or even gain benefit from it, profit I mean. Organic synthesis help us to know, to be able to know the content of the product that we are using, because it help by explaining the content of the product. For example, the characteristic, for example, the functional group, the characteristic of the functional group, and also how do we produce the product using the given information. Let's take vinegar as an example. The scientific name for vinegar is ethanoic acid. From the name itself, right, ethane means there are two carbon in the chemical formula, so hence that is why ethanoic acid is called ethanoic acid from the word ethane. From the chemical formula of the vinegar, which is CH2 COOH, COOH, COOH represent there is carboxylic acid presence in the chemical formula. Carboxylic acid is a functional group which is being explained in the organic synthesis subject itself. The other example for how organic synthesis is being used is that we are able to know the content of the shampoo. We often use shampoo to wash our hair every day, but we never know how can shampoo clean our hair. So through organic synthesis, we are able to know that there is sulfate contained in the shampoo itself, which helps to remove oil and dirt from our hair. There are two types of sulfates used, such as the sodium lauryl sulfate and sodium laureth sulfate. Both of the sulfates help us to clean our hair, to help our skin feel more cleaner and feels refreshing. As a consumer, we need to know about the product that we are going to use. We of course, as a consumer, we want to avoid unnecessary things from happening. For example, burning of our skin, irritation, inflammation, and all that. So with the knowledge that we gain from organic synthesis, we are able to differentiate what is good and what is bad for us. We can also use organic synthesis to produce the product that we need. For example, maybe emergency sanitizing agent. With the current situation that we are in right now, it is very useful for us. Thank you. There are a lot more examples that we can use from organic synthesis. There are many more out there. So this is just some parts of what is organic synthesis about. The most important thing is that we know what we are consuming daily. Even the food, the drinks, for example, the soft drink and all that. This is why organic synthesis is unique. With this subject, we are able to identify such good things for us, maybe gain some benefit from the knowledge that we gain from organic synthesis. Thank you.
Many of the materials we use today are made by chemical synthesis. Most of the new compounds made today are organic. Organic synthesis helps to understand the complex nature of natural products and offers several synthetic route choices from which to choose the most cost-effective and environmentally sustainable route. This technique is particularly used for preparing the synthesis of organic compounds with structures that are much more complex than and inorganic compounds. In green chemistry, it deals with synthesis procedures according to its classic 12 principles contributing to the sustainability of chemical processes, saving energy, reducing reagent and final product toxicity, reducing environmental and human health harm, reducing the risk of the global overheating, and allowing more fair use of natural resources and agricultural waste. In order to synthesize both well-known chemical compounds by more natural routes and brand new products, greener methods have been used. Greener path, including nanoparticles of metals, nonmetals, their oxides and salts, aerogels and quantum dots, can create a variety of nano-sized materials and composites. At the same time, by cleaner methods, classic materials such as cement, ceramics, adsorbents, polymers, bioplastics, and biocomposites can be enhanced or obtained. Several non-contaminating physical methods such as microwave heating, ultrasound-assisted and hydrothermal processes of ball milling, frequently in combination with the use of natural precursors, are major importance in the greener synthesis, as well as the solventless and biosynthesis techniques.
What is interesting and unique about organic synthesis? Organic synthesis performs key function to design drug for treating disease. It plays as the engine for understanding structure and reactivity. This science has found application in the production of molecules of commercial interest, in the construction of newer pharmacological active therapeutic agents derived from the rational drug design into synthesized complex neutral molecule, in the finding innovative approach to render this chemical science more efficient. The role played by the organic synthesis chemists in the pharmaceutical industry continue to be one of the main drive in the drug discovery process. However, the precise nature of the role is undergoing a visible change, not only because of the new available to the synthetic and medicinal chemists, but also in several key areas, particularly available in drug metabolism and chemical toxicology. As chemists deal with the ever more rapid turnaround of testing data, the influence their day-to-day decision. Objective of organic synthesis chemistry is to design and production of compounds that can be used in medicine for prevention, treatment, and cure of human or animal disease. There are two major considerations must be discussed in any drug design project. First, drug interact with molecular target in the body, so it is important to choose the correct target for the desired pharmaceutical effect. In other words, a drug that will interact is powerful and selective as possible for the target. Second, a drug after administration has an ability to travel through our body in order to reach its targets. Example of drug design by organic synthesis to prevent and cure against several lethal diseases such as HIV, malaria, TB, and the most important is cancer. What is cancer? Cancer refers to a wide group of disease caused by the cell that divide uncontrollable. It has been estimated cancer kill more people than any other form of disease. Modern chemistry play a crucial role in improving both diagnosis and treatment. Given the aim to discover the selective inhibitor, research scientists began by designing and making just a few of milligrams of several thousand new compounds before they found the magic bullet suitable for testing in patients. As soon as the milestone was reached, organic chemists need to devise a new method to rapidly make much larger quantities, for example in a kilogram, which would be needed for clinical trials. This was a new challenge: safety, environment impact, and speed. Skilled organic chemists work in the field used to latest development in synthetic organic chemistry to devise a new method involving just three chemical reactions to make the key building block for the synthesis. The new drug was tested successful in the clinical trials. So what is the example of this successful tested drug, for which is one of is Taxol. Taxol is currently one of the most effective and widely used anti-cancer drug for variety of cancer. Taxol is a chemotherapy drug used to treat breast cancer, and is name of the drug you may be hear or called by one of a brand name such as Taxol. Second one is Calichiamycin was developed and marketed as target therapy against non-solid tumor cancer, which is leukemia. The development of newer pharmaceuticals currently a critical and challenging task to the organic synthesis chemist industry. The vital interest of the medicinal and agrochemical industry in organic synthesis is often related with their natural occurrence. Similarly, medical and pharmaceutical field, also organic synthesis field, has been and continue to be a need for newer chemical entities with diverse biological properties. Thank you.
As you can see from the video shown just now, a drop test has been done on the watermelon. The fruit has been coated with a type of protective coating beforehand, which gives protection to the watermelon from splashing. The said coating is made by using organic synthesis. Thus, this type of coating can be made if one has enough knowledge in organic synthesis. Organic coatings are corrosion barriers between the underlying substance and the corrosive environment. They maintain durability of structures to provide resistance to the weather, humidity, abrasion, chemical resistance, toughness, and aesthetic appearance. Organic coating efficiency depends on the mechanical properties of the coating system, type, and concentration of suspended inhibitors, pre-treatment of the metal surface, adhesion of the coating to the underlying base, and other additives that inhibit substrate corrosion.
Coating formulation usually contains solvent, resin, binder, pigment, filler, and additive, which are organically synthesized. When applied to the underlying substance, they provide a continuous, homogeneous coating that prevents cracking and structure breakdown during stress, water permeability, and physical aging. Protective coating should possess low permeability, good cohesion, stability, and appearance over a long period of time to justify the cost. Thank you.